All right, what are waves? The power of waves. Where does the energy that powers your school come from? It may be from oil, gas, or coal. You also may have heard of using the sun or wind as energy sources. But did you know that ocean waves could be used as an energy source too? Mechanical systems placed in the ocean or along the shore transform the energy from waves into electricity. Unlike oil, gas, or coal, the energy from ocean waves will not run out. Although wave energy technology is still very new, many scientists are optimistic about its possible use around the world. All right, so discuss this question or just think about it on your own and then write your answer below. How might wave energy impact the environment? Consider both intended and unintended consequences. All right, what forms mechanical waves? You have probably seen and felt water waves while swimming, but did you know that many kinds of waves affect you daily? Sound and light are very different from water waves, but they are waves too. All right, characteristics of waves. What is a wave? A wave is a disturbance involving the transfer of energy from place to place. In science, energy is defined as the ability to do work. For example, the energy of a water wave can lift an object on the water's surface as the wave passes under it, but after the wave passes, the water is calm again. Most waves need something to travel through. For example, sound waves can travel through air, water, and even solid materials. Water waves travel along the surface of the water. A wave can even travel along an object such as a rope. The material through which a wave travels is called a medium. Gases such as air, liquids such as water, and solids such as ropes can all act as mediums. Waves that require a medium to travel are called mechanical waves. All right, so on this piece of notebook paper, I want you to summarize the text that we just read in your own words. So tell me everything I just read, but in your own words. All right, challenge. The news media, such as newspapers and television stations, carry current events worldwide. Explain how the way news travels is similar to the way a wave travels. All right, waves and energy. Energy is needed to make a wave. Mechanical waves form when a source of energy causes a medium to vibrate. A vibration is a repeated back and forth or up and down motion. Moving objects have energy which they can transfer to a medium to produce waves. For example, as you see in Figure 1, a motorboat's propeller can transfer energy to calm water. As a result, the particles that make up the water start to vibrate. The vibrations move through the water, resulting in a wave. All right? So, forming a mechanical wave. A source of energy in a medium can cause a mechanical wave to form. Draw an arrow from each box to the correct part of the photo. Then tell your reason for each choice in the boxes. So you're going to use the energy source box, the medium, and the vibration box. Draw an arrow from each of these boxes to the source in that picture, and then explain why you think it goes there. All right, what are the types of mechanical waves? Waves move through mediums in different ways. The three types of mechanical waves are transverse waves, longitudinal waves, and surface waves. These waves are classified by how they move through the mediums. All right, transverse waves. When you make a wave on a rope, the wave moves from one end of the rope to the other. However, the rope itself moves up and down or from side to side at right angles to the direction in which the wave travels. A wave that vibrates the medium at right angles or perpendicular to the direction in which the wave travels is called a transverse wave. Making a transverse wave on a rope forms high and low points along the rope. A high point on a transverse wave is called a crest, and a low point is called a trough. In Figure 2, you can see that the red ribbon on the rope is first at a crest and then at a trough. As the wave moves through the rope, the ribbon moves up and down between crest and troughs. The dashed line shows the rope's position before it was moved. It is called the rest position. All right, so motion in a transverse wave. When you shake out a bed sheet or move a rope up and down, you create a transverse wave. So here's what you're going to do. Label the crest, trough, and rest position, and then draw a vertical line through the purple arrows and a horizontal line through the blue arrow until it touches the vertical line. What angle did you draw? All right, and then for vocabulary. The word trough has more than one meaning. Write 2 sentences that use the word, one showing its everyday meaning and one showing its scientific meaning. All right, longitudinal waves. If you push and pull one end of a spring toy, you can produce a longitudinal wave like the one shown in Figure 3. Notice that the coils in the spring move back and forth in the same direction, or parallel to the wave's motion. A longitudinal wave vibrates the medium in the same direction in which the wave travels. Also notice how the spacing between the coils varies. Some coils are close together while others are farther apart. An area where the coils are close together is called a compression. An area where the coils are spread out is called a rarefaction. As compressions and rarefactions travel along the spring toy, each coil moves forward and then back. The energy travels from one end of the spring to the other in the form of a wave. After the wave passes, each coil returns to its starting position. All right, so motion in a longitudinal wave. Fixed points on a transverse wave vibrate up and down. Fixed points on a longitudinal wave, such as the one marked by the red ribbon, vibrate back and forth. Label the areas of compression and rarefaction in the diagram. All right, apply it. Sound waves are longitudinal waves. The picture shows an area of air as the compressions and rarefactions of a sound wave pass through it. The dots represent air particles. Okay, so you're going to write an R in the rarefaction areas and a C in the compression areas, and then draw what the particles should look like in area Z. So what do you think they're going to change to by the time they meet Z? All right, and surface waves. Surface waves are combinations of transverse and longitudinal waves. This type of wave travels along a surface that separates 2 mediums. Ocean waves are the most familiar surface wave. An ocean wave travels at the surface between water and air. When a wave passes through the water and anything on it vibrates up and down, like a transverse wave on a rope. The water also moves back and forth slightly in the direction that the wave is traveling, like the coils of a spring. But unlike the coils of a spring, water does not compress. The up and down and back and forth movements combine to make each particle of water move in a circle, as you see in Figure 4. All right, so looking at Figure 4. A wave moves the bottle in a circular motion. After the wave passes, the bottle returns to where it started. All right, so in the empty box, draw what the next picture should look like. All right, assess your understanding. Compared to the direction it travels, at what angle does a transverse wave vibrate a medium? How are transverse and longitudinal waves alike, and how are they different?